Alexandr Kara worked, for example, in Microsoft when he worked on Skype core library written in the C++. And then he moved to Google where he worked, for example, on YouTube. Most of the time he was writing code in the C++. Alexandr joined us last year in the outreach, and again, also he writes now mostly in the Go. So he will provide you insights about his experience of switching from C++ to Go.
This talk, going from C++ to Go, is about my experience when I started coding in Go last year. It's not meant to be a neutral language comparison. It's just a collection of my observations, and it's up to you to draw your conclusions. So I was writing C++ code for over 10 years. In my last job, I was had a side project as a C++ readability reviewer. So I was mentoring people about the common style of C++, about like what features to use, what features to avoid. And I was getting quite comfortable in a subset of the language that I was using. It was moving. It was, as the language was evolving, for example, C++ 11 was a big update. I was learning new things. And very importantly, I was also forgetting or trying to forget old habits, old things. Because C has C++ has dark corners that are better avoided. And therefore, even though I have been working in C++ for a long time, I still don't know the language fully. There are still parts that I don't know. And since I only have less than a year of experience with Go, please take what I say with a grain of salt. So after my personal history, I have some things about the history of the languages of C++ and Go. So curiously, there are some personal overlaps in both languages, or between C and Go. Because Ken Thompson, who is one of the authors of Go, he was also one of the authors of the B language, the predecessor of the C language. And Rob Pike, whom Pharaoh mentioned already, he was, together with Ken Thompson, he was a member of the Unix team, and Unix is also like very closely related to C. But Go is a much younger language. C++ is over 30 years old. It appeared in 1985. And the predecessor C is almost 50 years old. It's like a very old language. And Go appeared a bit more than 10 years ago at Google. And interestingly, it was not the first language that Rob Pike developed at Google. Before that, there was Sozel, which was a quite obscure language for writing data processing pipelines. You declared inputs that you got into the program, and you could fill outputs. And it was the syntax was quite weird, quite unusual, and it was a very special purpose language. But it had quirks. People didn't like it too much, so Go replaced it in the data processing pipelines job. And unlike Sozel, it's a general purpose language. Similarly to C++, it's statically typed, it's compiled, unlike C#. But C++ is a very old, powerful, and complex language which has standards having hundreds of pages. And Go is a more modern language. It has a lot less features. It's lacking generics, although they are coming. It doesn't have operator overloading. It doesn't have distinction between references and pointers. It has much simpler access control, which also Fer talked about. It does some things on that C++ doesn't. It has features above C++. It has garbage collection, which C++ doesn't. But C++ handles this with a different approach. C++ uses libraries to deallocate memory, but you need to be careful. You can make problems if you use row pointers. That's why, for example, at my previous company, we avoided row pointers, and row pointer was a code smell. Instead, we used smart pointers, most commonly unique pointer. And Go, other thing is Go makes some other decisions for the programmers so that they don't have to take care of whether to place the data on stack or on the heap, and has safety features. Like if you need more data on the stack is automatically resized, and all the data is copied, and you can use the new stack. In C++, Stack Overflow is a really hard thing to debug, and maybe that's one of the reasons the Stack Overflow website uses this name. And because Go was created in a time where computers and processors had lots of cores, it has a built-in concurrency. In C++, you can also get concurrency, but it's not in the language, or some parts are in the language recently, like they started trickling in C++ 11 with like memory orderings, etc. And then there are new things happening and appearing, but they are not part of the language, unlike in Go. But Go is not too radical a departure from C. It has some commonalities, and, for example, doesn't guarantee concurrency safety, unlike, for example, Rust, which has a borrow checker. And unlike C++, which only focuses very narrowly, as Ferro mentioned, Go has a huge ecosystem around it. It has the infrastructure to download dependencies over the web, to build, test. I won't repeat what Ferro was talking about. But you can see that, like, if you look at it from the top, you can see the most visible differences, but also most trivial things that don't really matter that much, but that you notice. That you don't have to put semicolons at the end of the lines. You have a different assignment operator if you create a new variable versus if you update an existing one. But unfortunately, with another feature, which is assignment of multiple values, this kind of loses appeal, because what if you have like one old and one new variable? But still, it makes it a bit easier to spot new variables, and also it makes it very easy to return errors from the functions, as I will talk about later. Another superficial difference is the switch statement. It's much more powerful in Go. You can switch over strings. You can switch over expressions that are evaluated at runtime over like return values from a function. And one thing which Go did right, and C++ is very dangerous in, is that in C++ by default, if you don't add a case in the switch with a break, it automatically the code execution continues on the next case, which is so difficult, so error prone that in a lot of companies there are tools to spot these problems and disallow checking in code which has this. But still, the language didn't remove it and cannot remove it because of backward compatibility. So that's one thing to note. But a more fundamental thing is how resources are cleaned. So C++ uses RAII, resource acquisition is initialization. So on the right side, you can see the C++ example, which in this case is much simpler. Because when you create the file object, whenever it gets out of scope, so at the end of, in this case, at the end of the function, the destructor is called, and the destructor will usually, if the object is well behaving, will free the resources, free memory, and also free the file handle, close the file, etc. In Go, the approach is a bit different. You usually return the value and error separately, and in each case, you have to check the error and return from the function that caused it. This is a bit tedious. As you can see, the example is longer. But in C++, in companies that don't use exceptions, which also like some big companies avoid using exceptions, so they had to come up with macros to check the return type and basically do the same as what Go does. And on this slide, you can see another feature of Go, which is the defer statement. And it's also like very unintuitive, or was very unintuitive for me coming from C++, because it's going to call a function at the end of the current function, not at the end of the scope, but at the end of the current function. And interestingly, it looks like a call to src.close, but it's not a call to src.close. It just would call this function at the end. And it's quite heavily used if you need to free some resources. But C++ has exceptions, uses exceptions for error handling in general. And Go also introduced something along exceptions, which I find is bolted on the language in a quite an interesting way. Go has panic, which terminates the current function and like unwinds the stack. And then in the calling function, you can, in the defer body of the defer function, you can have a recover call, and that catches the panic value as if it was an exception in C++. So it has a similar thing, but it's much less used than in C++. Another thing is, as also Ferro mentioned, is that a lot of things are built in the language in Go, where C++ has everything, not everything, but a lot of things has in the library. So for example, maps, slices, Go routines, channels, all those are part of the language, and also some functions that manipulate those, like make. If you want to create a slice, which is like a resizable array of a certain capacity, you have to use the make method. And it's like a built-in method that you cannot really express in the language. You cannot write it in the language. It's a built-in, and it's like impossible to emulate. Similar with append. If you want to append this slide, you call the built-in append function, which is quite different from C++, which has methods on the data type and has its disadvantages. As you can see, it's much more verbose. Some people omit the std namespace, but I added it for like so that we can see how long the writing is. But it has its advantages as well, because you can have different flavors of maps. You can have unordered maps, which are hash tables usually, or ordered maps as implemented as some kind of balanced or unbalanced trees. You can use maps that have value inside the hash table, or maps that store the value somewhere else, etc. Another difference between Go and C++ is, as Ferrum was talking about in detail, there is no inheritance in Go. There is composition, and this is also a big difference in how much you use inheritance in C++. You have to learn a lot.
I'm sorry, I want to ask you, for me the sharing is stuck. I don't know if...
what slide do you see?
Cleaning up after resources, C++ uses, the resource initialization.
Sorry, thank you. Yeah, let me stop and restart the share.
Mm-hmm.
Is it moving now?
Yes, it's better.
Yeah, sorry about that. So yeah, this was the example. So now to the, so maybe let's go back a bit. So this was the example with panic and defer and recover versus C++ way of throwing exceptions. And this is how C++ uses containers, unordered map in this case. So another thing is for the type system, as we talked about, there is no inheritance, there is composition, and it's also one of the traits why Go is more modern, because these days inheritance is thrown upon by many people. So it's like a modern thing to use composition instead of inheritance. And another thing where C++ is different from Go is how it treats types. So interestingly, like C++ has a very strict type system that where types are compatible if they have a common, like custom types, user-defined types, if they have a common base class, or classes have are compatible. But in Go, it's enough if they share the same structure. And this is kind of in between C++ and some of the less strict languages that where if the object has a method, you can call it, and you don't care about the whole set of methods. So in Go, it's a more strict because you have to implement an interface like all the methods, but you don't have to have a common base class or declare that you implement the interface. And also there is no automatic conversions in Go. So for example, int and int64 values are not convertible. So as you can see on this slide, this can lead to some problems. If I have a variable of type int64 and I compare it directly with the one, then it's fine. The compiler might tell me that I have to cast it. But if I pass this somewhere where it doesn't have a strict type checking, because it accepts the most general interface, then the first call will succeed, but the second call will fail, because it will not tell you at compile time that 1 and x are of different types, but at runtime it will fail and it will say 1 doesn't equal 1. So this is like one pitfall which is good to remember when you work in Go. But this should be solved with generics, as like Faro said, like he's looking forward to generics. I think this is a good reason for being helpful. For memory management, Faro talked in detail about the garbage collection, that you don't need to free things. This has positive sides, but has also negative sides, that it's harder to keep weak references. Like you keep a reference to something, and if there's memory pressure, you are fine with, or if like nobody uses it, you are fine with it disappearing. But otherwise, you want to keep it in cache. So this is harder to implement in Go, because Go has something like which is called a finalizer, and it's called when the garbage collector wants to free the object, it can provide a finalizer and save itself. So it's possible to use this to pretty much implement what are weak references or weak pointers in C++, but it's a bit more work and it's like bit less intuitive. And I talked about other aspects of memory management, like the compiler decides whether a variable will live on the stack or heap. And this has an advantage that you don't have to think about it too much, and returning by value is recommended. In modern C++, this is the same thing. Returning by value is recommended, but you have to be mindful about the potential stack overflow. So you cannot put something too big on the stack, while in Go you can, because the stack will not overflow. So to summarize, with like 3 aspects of the differences between Go and C++. For the speed of development, Go is arguably much faster than C++, because the language is simpler to learn, it has less pitfalls, but it has slightly lower performance and less predictability because of garbage collection pauses. But on the other hand, Go it's harder to create some security problems in Go, because it guards you against buffer overflows, indexing out of bounds, etc. And also, if you use channels, it's easier to write concurrent safe programs, although it's not guaranteed. So my personal pain points for Go is one thing I didn't talk about yet, and that's there's no equivalent of C++ const. Go has a const, but it's just for compile time constants. But C++ has const expr for compile time constants, but it can even return them from a more complex calculation in a function, or like from a template instantiation, etc. And the const, as C++ has it, is very useful, because you immediately know that a variable will not be changed once you look at the line where it's created. For members that are const, it's also very easy to reason about that they won't change after the construction, and you cannot accidentally modify it. So we had a code style that encouraged using const in like as much as you could, because it had like a positive effect. But unfortunately, Go doesn't have this. Also, it's a bit harder to enforce invariants on data structures, because in C++ you can guard your data structure very closely. You can have a constructor which puts it into a valid state, into a consistent state, and all the methods, if they get object in the consistent state, they return an object in the consistent state. So you are sure that it's consistent. In Go, it's you can have like the kind of factory method that's kind of like a constructor, but still you can access all members from inside the package, and the package is usually bigger than what the C++ class is. So you have to be a bit more careful around enforcing invariants, and it also encourages you to make your packages a bit smaller, so that you can mentally guard against all the possible cases, all the possible excesses. Yeah, Go doesn't have templates or generics, but they are coming. That's one thing that's going to be solved. It doesn't have operator overloading, for example, or so that if you have types that are naturally addable, where you can add them or subtract them, like time intervals, durations, sets, you have to write functions that do this and call them. And for method overloading, you have to think about the name of a different method that basically does the same as another one, just with different kind of inputs. And other thing which is not really a problem, but this which kind of intellectually bothers me, is that some things are built in and cannot be implemented in a library, like make, new, select, or even the string type, which in C++ is a library object. So thank you for your attention. These are some of the interesting links, and if you have some questions, I would be happy to answer them.